Welcome students. Welcome to the lecture series on laser. This is a part of your module optics. So in today's class we are actually discuss about the laser construction, how a laser is constructed and the various parts related to a laser. So it is pump source, laser medium and optical resonator. We will come to this one by one. Let's start with this laser construction. So the laser system consists of three important components: a pump source, laser medium and optical resonator. So what is pump source? The pump source or energy source is the part of a laser system that provides energy to the laser medium. To get laser emission, first we need to produce population inversion. So actually your pump source gives the population inversion. The source of energy supplies sufficient amount of energy to the laser medium by which the electrons in the lower energy electrons are excited to the higher energy state. So to get population inversion, you have to excite the lower level electrons to the higher state. So how will you do it? By using pumping. Pumping means you will supply external energy to the lower level electrons so that it gets excited to the higher state. Okay. So there are various methods of pumping. So one of them is optical pumping. So in case of optical pumping, you supply the energy to the lower level electrons by means of photons. So you heat the electrons using photons. It absorbs the energy and gets excited to the higher state. Then it decays spontaneously to the intermediate state, which is a metastable state. So you get population inversion. You get more population compared to the lower state. Okay. So you get population inversion. Then there will be stimulated emission from this state to this state. And by this process you get lasing action. So you transfer energy in terms of photons. It gets excited to the higher level state. It decays spontaneously to the metastable state. Then you get the population inversion. Then there will be stimulated emission between these two levels, and it will be coherent as these two levels are fixed. So this is basic working principle of any laser. Then comes collision of first kind. Here you excite the electron by hitting it using another high speed electron. So actually there will be transfer of energy by inelastic collision. So there will be inelastic collision between these electrons and there will be transfer of energy so that your electrons get excited to the higher level state. Then again it decays spontaneously here and it will get population inversion. The procedures here are same for all the states. The difference is how you excite the electrons to the higher state. Okay. There comes collision of second kind. Here at first, by first electrons you transfer energy to one atom. Okay. So the electron slows down and you excite one atom. Then this excited atom transfer its energy to another molecule of another system or another gas. Okay. So another material, you can better say. So by this process, this your B, another material, gets excited to its metastable state. So that's why it is called second kind. Means you are having two steps. In the previous one you are having one step. That's why it is called collision of first kind. Here you have two steps to excite the electron. Then comes thermal pumping. It is same, but only the energy is transferred by heat energy. So in optical pumping it is light energy or photons. Here it is heat energy. Again you excite these electrons to the higher energy state. It decays spontaneously to the metastable state and you are getting population inversion. Now laser medium. The laser medium is a medium where spontaneous and stimulated emissions of radiation takes place. So in this medium actually your lasering action is taking place. So thus your light amplification is achieved in laser medium. So in every medium you cannot get laser action. There is specific medium where you get lasing action. Laser medium is also known as active medium or gain medium because you are getting the amplification. The laser medium can be various types. It may be solid, say UV laser, say liquid, your dye lasers, and gaseous, say your helium neon laser. We will discuss about this kind of laser. Then what is optical resonator? So the laser medium is surrounded by two parallel mirrors which provide feedback of the light. One mirror is fully reflective, whereas another one is partially reflective. These two mirrors as a whole is called the optical resonator. So optical resonator is also known as optical cavity or resonating cavity. Okay, so you will have this kind of system. The light in the laser medium is reflected many hundred of times between the mirrors before it escapes through the partially reflecting mirror. The light escaped from the partially reflecting mirror is produced by the stimulated emission process. It means, say, inside this you have your laser medium. So here you get your stimulated emission and you are getting the laser light. Now your laser light gets reflected between these two mirrors and it is amplified. It gets reflected number of times so that it can induce or say stimulate another emission in another molecule. So there will be an amplification of output laser light. That's why you are having two reflecting plates, and there will be hundreds of times reflection. And after one side you have less reflection, so that there will be your laser light will come out from this plate. This is completely reflected. There will be no chance that your laser light is coming from this side. There is less reflective plate. So your amplified laser light will come out from this plate. Okay. This is the working principle of your optical resonator. You are having two reflecting plates. Your laser light is getting reflected in between it, and after that it is coming out from this side. Okay. So what we have learned today about the pump source, about laser medium and optical resonator. So all about your laser construction, how your laser works and how you can construct a laser. Thank you.